Hi, Assalamualaikum. We are from Group 2, and this is our project presentation for welding engineering. Our project's title is Mini Toolbox. So, this is our team members. First of all, our beloved leader, Muhammad Harith, followed by me, Muhammad Hakim Hasyun, Muhammad Faris bin Sarizal, Daniel Hakim, and also Amin Mazlan. Okay, so welding has evolved significantly from ancient techniques used by societies like the Egyptians to the advanced methods developed during the Industrial Revolution, such as arc welding and coated metal electrodes. Fundamentally, welding joins materials using heat, pressure, or both, creating strong connections upon cooling. Unlike brazing and soldering, welding melts the base metal, forming a robust joint. Key elements include filler materials and shielding gases to maintain joint integrity. Our project focuses on designing a lightweight portable toolbox that maximizes space and organization, ensuring essential tools are easily accessible and protected, enhancing efficiency and productivity across various tasks. Okay, so moving on to objectives and design features. For the objectives, we have multiple objectives, which is first of all, we want to build a versatile, lightweight toolbox for efficient tool storage. We want to enhance productivity by reducing tool misplacement and damage. We want to design a project that has at least one degree of freedom. We also want to design a project that has more than two welding points. For the design features, it is lightweight for easy transportation. It is also it also has internal sections and holders for various tools. Next, for our problem statement and scope of design. For our problem statement, we have three main issues. First of all, which is transportation issues, lack of organization, and also safety hazards. So for the transportation issues, we have for example, heavy and cumbersome toolboxes are difficult to transport, leading to inefficiency and fatigue. For the lack of organization, poorly organized toolboxes cause frustration and waste time searching for tools. And last but not least, for safety hazards, misplaced or damaged tools can result in safety risk and decreased productivity. For the scope of design, we also have three main points, which is design phase, material selection, and fabrication and assembly. For the first point, which we want to identify common tools and storage requirements. We also want to create an ergonomic and space-efficient design. For the second point, we want to choose lightweight, durable, and wear-resistant materials. For the last point, precisely cut and prepare materials. We want to use secure joining techniques for sturdy assembly. We also want to incorporate compartments and organizers within the toolbox.
So next, for the welding method, in this project, we only use MIG technique, which is metal inert gas welding, which is for your information. This technique involves an electrode with continuous solid wire, which is from the steel or aluminum material. Other than that, for the arc formation, we also an electric arc between wire and workpiece melts the electrode. For the shielding gas, it uses the argon and also CO2 or oxygen protect well, pull from contamination. And in this technique, it also involves several equipment, which is power source, wire feeder, welding gun, ground clamp, and also shielding gas supply. So why we use MIG welding technique? So because there are several benefits for us, which is firstly, it has fast welding speed, which can make our project complete early. The second one, it produces minimal spatter and high quality welds, which can make our product solid without broken or cracked. And the last one, since our material still is thin, so it suitable for us to use this technique, which is the MIG suitable for thin materials. Okay, so for this diagram, you guys can see this the 2D drawing with welding symbol for our mini toolbox project. Okay, next for this image or photo, we show you the exploded view for our 3D model, which is mini toolbox. So we have four views, which is the first one is ISO view, isometric view. The second one back view, the third one side view, and the last is top view.
For our project, we decided to do the simulation using Fusion 360. The main purpose we do this simulation was to understand the material properties towards the heat so that we can produce more efficient products. By doing thermal analysis, we can determine the possible safety risks linked with extreme temperature. In this simulation, we set the highest temperature to 1500 degrees Celsius and maximum power to 3000 watt. The two analyses that we run were temperature distribution and heat flux distribution. These are the results of our toolbox simulation using the Fusion 360. For the first image, is the result of temperature distribution for all of the welding parts. Next one is the result of heat flux distribution from the welding joint. These are the images for the close-up view for temperature and heat flux distribution for hinge joint. Next is close-up view thermal analysis for handle welding, which are hollow steel and sheet metal joint. The last analysis is the structural analysis. Structural analysis is important in order to investigate behavior and structure materials. Structure can resist the load applied to the material without failure or deformation. These are the results that we obtain by running the simulation in the Fusion 360. For this simulation, we set the maximum load to 10 kg and we got the safety factor for our toolbox, which is 15. This is the safety factor that we obtain for our toolbox. And this is the total displacement for our toolbox that caused by the load.
This is the product demo for the Mini Toolbox. The Mini Toolbox allows you to store things such as tools and screws. The Mini Toolbox features a hinge that allows 1 degree of freedom and a smooth opening and closing motion. Other than that, for this project, we only use fillet weld for all the welded spots. Whereas for the finishing, we used yellow paint for the side walls and the cover, and black paint for the handle and the hinge. Now we will be demonstrating the load test by using actual tools. The tools used are approximately 10 kilograms. When we shake the toolbox with the tools in it to simulate real-life usage, we can see that the toolbox can withstand the load without any problem.
Okay, next we proceed with the conclusion. To conclude this, we what we get is from this project is three main things, which is it is this project give us hands-on learning experiences. This project has been a great opportunity for us to learn about the true challenges that go into the planning, estimating, and manufacturing a welding product, which for our case is the mini toolbox. We get to learn how to assemble the sheet metal into the functional mini toolbox that can assist user to bring the tool anywhere effortlessly. And next, what we learn is we get to know better in understanding the process of the welding process. The completed project itself demonstrated the effectiveness for this case, which is MIG welding, which are versatile, relative ease of use, strong weld, and fast welding process. From this project, we get to know that MIG welding is a very versatile welding process, and it also very easy to use, since we student doesn't get a very completed detailed training in welding process, but we get to manage to weld by using this MIG welding process. And we also noticed that MIG welding process is a very fast welding process, and we get to complete our project within 3 weeks. And lastly, we get to know better understanding of the analyzation of the welded product. A deeper comprehension of the welding process itself is attained by the examination of the product before doing the welding process. What is meant by this, we try to make a simulation, make a analysis, structure analysis, how and if the welding process can successfully being do. And with this analysis structural, we get to make it what is possible with energy welding while ensuring constant quality. And by doing all of the analysis, we get to know if the welding process can perfect perfect fully executed. And from our analysis, we found that this welding process can be made. That is all from us. Thank you.